Hello, this is 4.5, drawing conclusions number 2. This time we're going to look at 4 more ways to draw conclusions. So perpendicular lines, alternate interior angles, vertical angles, and bisectors. So first one we're going to talk about is perpendicular lines, and this one I don't think is entirely new to you, but perpendicular lines are going to look like this, and they are going to create two congruent 90-degree right angles. So perpendicular lines create two congruent angles. And they're always going to be right angles or 90-degree angles. Okay, so an example of what this would look like in our triangle unit, I have the triangle ABC here, and maybe I tell you that I'm going to create a new segment, and I'm going to call it CD. So I'm going to say CD is perpendicular, or we could use the words, but that's the symbol for it, to segment AB. All right. If that is the case, then we can fill in a congruent set of angles right down here. So at that point, you could say that angle ADC is congruent to angle BDC because of perpendicular lines. All right, next one. Alternate interior angles, again, not entirely new to us. We did this a couple units ago, but that's where you have your your parallel lines and a transversal. So if these guys are parallel and you have a transversal, your alternate interior angles are those ones that are kind of like the insides of the letter Z. So kind of picture the letter Z. But if you have parallel lines, then alternate interior angles are going to be congruent. So creates congruent angles when lines are parallel. So again, jumping into an example of what that looks like in our triangle unit, we might have something that looks like this, where you have two parallel lines and then that transversal cutting through. Your alternate interior angles would be here and here. So I'm going to throw some letters on here just so we can talk about it a little more. I'm just going to go A, B, C, and D. So now we can say that angle CDB is congruent to angle DBA or ABD. I'm going to go ABD because those guys are alternate interior angles. Next one, vertical angles. Again, not entirely new to us. Vertical angles are those angles that if you can kind of find the letter X, they're going to be across from each other. Okay? They are always going to be congruent. So anytime you have that situation, you are always going to end up with two congruent angles. So here's an example of what that would look like with triangles. Again, I'll add some letters here. We'll go A, B, C, D, and E. And we have these two angles right here that are across from each other. Those are our vertical angles. So at that point, we could say that angle ACB is congruent to angle ECD. And then last thing we need to talk about here is bisectors. There are two types of bisectors. Bisectors means to cut in half. Cut in half. So we could have an angle bisector. So an angle bisector would split an angle in half. Or we could just have a regular bisector, which would cut a side in half. Or cuts a side into two congruent parts. All right, so two examples here. First one is an angle bisector. So I started with a square, and if I did this, Okay, and let's add some letters again. A, B, C, D. If I said that CB bisects angle ABD, that would mean that I cut this angle here in half. So now I can say angle, switch colors here, angle ABC is congruent to angle DBC. All right. And then a regular bisector would cut a side in half. So again, we'll add some letters. I'll go A, B, C, and D. So if I said that BD bisects AC, that would mean that we created two congruent parts. So now we could say segment AD is congruent to segment DC. All right, so go ahead and practice. In this practice, you're just going to be adding some marks to some diagrams and then explaining which of those 4 properties or definitions you used.